Okay, so we are graphing quadratic functions today. Let's read the directions first. Sketch the graph of each function. List the y-intercept, axis of symmetry, vertex, and x-intercepts if they exist. Sorry, you couldn't see that part. X-intercepts if they exist. So some of them will not have x-intercepts. So what we're going to start with is we're going to find the axis of symmetry first, which uses the formula x equals negative b over 2a. So if we look at this equation, b is 2, and I have negative x squared, so that means that a is negative 1. I started to write ax, I don't know why. So a is negative 1. So if we put this in, I'll have negative 2 over 2 times negative 1, which just makes it negative 2 over negative 2, which means 1. So that axis of symmetry is going to go in at 1. And we can just put in a vertical line. They usually make it dashed. It's not officially part of your graph. It's just a line of symmetry that kind of lets us know where the middle of the graph is going to be. And then I'm going to go ahead and set up my table, and we'll just find the rest of the vertex while we're in the middle of it. So if we set up our XY table, I'm going to leave a couple blank spaces, and then I'm going to put 1 in the middle. So if I go back from 1, I would have 0. If I go back one more, I'd have negative 1. So I'm just going back 2 full spaces. And then if I go forward from 1, I would have 2 and 3. And we're going to put each of those in to find the point. So the 1 that we just put in from up here, that's where we're going to find the vertex. So if you want to do that one first, you can, just to have that point in the middle and kind of see where that's going to go. So the equation is negative x squared plus 2x. So it'd be negative 1 squared plus 2 times 1. And this negative will not go in the parentheses because it's totally separate from what the 1 was. So this would just come out negative 1 plus 2. If you type it all into your calculator, you'll get 1. So 1, 1 is my vertex. So that's going to go right here. Now let me ask you this. Is this parabola going to open up or down?
Down.
Down. How do we know?
Because the A is negative.
Because the A is negative. We know it's going to make kind of a frowny face and go down. So we're just going to keep that in our minds. I've even had students just kind of sketch the little upside down parabola right there to keep that in their minds. So then if something goes haywire, they know that's what it's going to look like. It's going to start from here and it's going to go down. So we're going to go ahead and put all of these numbers in. So I'm going to have negative 1 squared plus 2 times negative 1. Notice when I'm putting a negative number in, I put it in parentheses. With your graphing calculators, you will want to do that as well. If you type it in correctly, you will get negative 3. So negative 1, negative 3 would be over here. 0 should be an easy one because we're going to have negative 0 squared plus 2 times 0. So any guesses on what that's going to come out to be? 0 squared plus 2 times 0. 0. So 0, 0 is going to be a point on the parabola. And then if we put in 2, we'll have negative 2 squared plus 2 times 2. And we get 0 again, which we should because this should come out symmetrical. It should be the same on both sides. And for the next one, we should get negative 3. But I would encourage you to go ahead and try it on the calculator when you do these just to kind of double check that the first half of your parabola went well. So negative 3 is what I got.
Have parentheses on the 3?
Not necessarily. Well, on this part, you would get by with this one since you're not putting a negative in. Yeah. Okay, so if we connect it, this is what it looks like. And you could do more points to the left and more points to the right. I like to have at least 5 points because you can kind of tell where everything goes. So let's just go through the list. We sketch the graph. It wants the y-intercept. So where does it go through the y-axis?
0.
0. And we could get that from the equation because there's no c. You could make a little plus 0 on the end. So my y-intercept is going to be 0, 0. My x-intercepts, we don't have to actually factor to find because we can see them right here. It's where it crosses the x-axis. So it crosses at 0, 0. That's an x and a y-intercept. It also crosses the x-axis over here at 2, 0. The vertex we already had up here. We can just write it again to be thorough. So the vertex was that first point that we found, 1, 1. So let's see. Y-intercept, oh, the axis of symmetry. So the axis of symmetry, I guess I should have written it down when we first did it. We got x equals, and there's a bunch of stuff, 1. X equals 1 is the equation for that, if you just want to stick that up there. But that's just going through and finding all the information, which we should be able to mostly read off the graph and the table. And if you could not find the x-intercepts on the table or on your graph, and you know that there are some, that's when you can use the factoring to figure it out. But a lot of times you'll just find it just by putting the numbers in. Okay, so let's look at number 2. So our first step is just to find that axis of symmetry. X equals negative b over 2a. So b is going to be 4. A is going to be positive 1 because there's no number there. So I'm going to have negative 4 over 2 times 1. So that is negative 2. So that means on the graph, this is my axis of symmetry. So if you just want to write x equals negative 2 as the equation for that line right here on the graph, that'll work. It won't be in the way up there. Let me ask you this. From the equation, tell me what the y-intercept is going to be before we do anything else.
5.
5. So this number right here means that it's going to go through the y-axis at 5. And the reason is that's what's going to happen when I put in 0. These are going to go away. We get 5. So I could go ahead and say that my y-intercept is the point 0, 5. I just got that out of the equation. Is this going to open up or down? So we look here, it's positive. So it means we're going to get a smiley face, right? Parabola is going to open up. And so we've already figured out a lot of information without ever making the table, without doing tons of math. Just kind of inspecting the equation, you can get a lot of information. All right, so let's make our x, y table. And remember that this up here, the x equals negative 2 is what you want to have in the middle. So we want to go 2 numbers back and 2 numbers forward. So if I go back from negative 2, I'd have negative 3, negative 4. If I go forward, I would have negative 1 and 0. And we're going to put all of those numbers into the equation and see what we get. Let's do the vertex first, because that's this point here in the middle. So I would have negative 2 squared plus 4 times negative 2 plus 5. So if I put that into my calculator, or just do some mental math, this would be 4 plus negative 8 plus 5. We end up with 1. So negative 2, 1, which is way down here, is going to be my vertex. And if I want to just write that down here, because I know I'm going to have to anyway, and go ahead and do vertex negative 2, 1. And then we can put the other numbers in and see how the rest of this shakes out. So if I put in, let's just start at the top. If I put in negative 4, it'll be negative 4 squared plus 4 times negative 2 plus 5. So it'd be 16 minus 8, which would be 8 plus 5. I'm sorry, I did that wrong. 16 minus 8. I have 5 written down here. I'm trying to figure if that's right. 16.
Would it be?
What did I do?
It would be negative 4.
Oh, negative 4. I wrote it down wrong. I'm like, this isn't right. So it'd be 16 minus 16 plus 5. Okay, good. Glad you guys are good at math. All right, so negative 4, 5 is going to be on the graph over here. And that, look, that matches this point that we had for the y-intercept a second ago. We put in negative 3, we'll have negative 3 squared plus 4 times negative 3 plus 5. So it'd be 9 minus 12 would be negative 3 plus 5 would be 2. So negative 3, 2 would go right here. So negative 1 should give me 2 also, but it's always good to check. So this would give me 1. minus 4 is negative 3, plus 5 would give me 2. And so I have 1, 2. And then if I put 0 in, it's just 0 squared plus 4 times 0 plus 5. So this is going to be 0 plus 0 plus 5. We get 5, which we actually already marked by using the y-intercept from up there. Okay, so we've done the axis of symmetry, we did the y-intercept, we did the vertex, and it says x-intercepts if they exist. So if you look at this does not cross the x-axis at all. So for the x-intercepts, I'm just going to say none. If your vertex is above the x-axis and it's opening up like this, you know just by using a little bit of logic that it's not ever going to cross this. Right? So sometimes that happens. We're going to have a couple of those where they just don't cross the x-axis.
I swear this pencil like actually hates me.
I'm sorry. Okay.
Every problem I do.
Give a second to write this all down. We'll get this finished up. Did you get it? Okay, so let's take a look at number 3. So we'll just start with the vertex, or with the axis of symmetry rather. So x equals negative b over 2a. So b is going to be 8, and a is just 1 again. So I'm going to have negative 8 divided by 1. Gosh, that's hard. I get x equals negative 8. We could just box that here if you want. I'm sorry, over 2 times 1. So that'd be negative 8 over 2, which makes negative 4. So since the computer designed these graphs to fit everything, I should try to make sure it fits on the graph. Okay, so there it is. That's the axis of symmetry at negative 4. And so when we make our xy table, we're going to put negative 4 in the middle. And that's where my vertex is going to come from. And then we'll just put in some numbers and get this going. So if I go backwards from negative 4, I'd have negative 5, negative 6. If I go forward, negative 3, negative 2. And if you want to go the other way, negative 2, negative 3, negative 4, it doesn't matter. Just realize that your points are going to go from right to left when you graph them. So if we're putting these into the equation, negative 6 is going to be negative 6 squared plus 8 times negative 6 plus 12. And I have already done that on my calculator. You actually end up with 0. So negative 6, 0 will be that point there. Then if we put in negative 5, I'll have negative 5 squared plus 8 times negative 5 plus 12. And I've already done this one as well. Comes out negative 3. So negative 5, negative 3 is going to be right there. If we put in negative 4, we'll have negative 4 squared plus 8 times negative 4 plus 12, and it comes out negative 4. So negative 4 is right there, and that's my vertex. I know that because that's the point that's on the axis of symmetry. So I'm going to go ahead and put vertex negative 4, because that's one of the answers that we're looking for. And then if I put in negative 3, it should come back up to make this symmetrical. It's always good to check, though. Sometimes when I do the second half, I find a mistake on the first half. So negative 3 squared plus 5 times negative 3 plus 12. If I put that in, we do get negative 3. So negative 3 is right there. And then you should be able to go, okay, I think it's going to hit at negative 2 to be symmetric, but we'll check it just to make sure. And so these are just a nice one to just put in the calculator to save you some time. Or you can do it in your head. This would be 4 minus 16 is negative 12 plus positive 12 is 0. And we get this point right here. And we can go ahead and connect that. So we can see the x-intercepts pretty easily. It goes through the x-axis at negative 6, 0 and negative 2, 0. What we cannot see is the y-intercept. It's going to go up quite a ways before it hits the y-axis. So how do I find the y-intercept if I can't see it on my graph? There's a really easy way.
Factoring.
Not factoring. To find the y-intercept,
12.
we just go to this 12. And remember that it's on the y-axis, which means it's going to be 0, 12. So the y-intercept is just 0, 12. So I know it's going to have to go up quite a ways before it's going to hit the y-intercept. But I can get that just out of the equation right here, because I know if I put 0 in, these will just go away, and we get 12. So even if I can't see it, and it didn't show up on my graph, I can still figure it out. Okay, almost done. So if we go over to number 4, we'll start with x equals negative b over 2a. So b this time happens to be negative 18, and a happens to be negative 3. Finally, an interesting one. So I'm going to have negative 18 over 2 times negative 3. So it's going to be positive 18 over negative 6, which will be negative 3. So at negative 3, there's negative 2. At negative 3, we'll put in our axis of symmetry. If you want to just go ahead and write x equals negative 3. For the axis of symmetry, we'll already have that figured out. And then we can make our table. So negative 3, we want to be in the middle because our vertex is going to be at negative 3. So we go backwards, I'd have negative 4, negative 5. Forwards is negative 2, negative 1. And we'll put all of those numbers into our calculator, into this formula, and we'll come out with the numbers. So for the sake of time, I'm just going to tell you I put negative 5 in for x, and I got negative 13. Put in negative 4, I get negative 4. Put in negative 3, get negative 1, negative 2, negative 4, and negative 1, negative 13. So I just put all of these x's into the equation and plug them in the calculator like we did on the previous 3 problems. So my vertex is going to be at negative 3, negative 1. Right here is the vertex. We can go ahead and write that down. And then negative 4, negative 4, negative 5, negative 13, and then negative 2, negative 4, and negative 1, negative 13. This is a really skinny little parabola. And it's a similar idea to slope, that number on the a in front of the x squared. If it's a number bigger than 1, it's going to make it kind of skinny. So we have the vertex there. I cannot see the y-intercept, but what would my y-intercept be? Negative 28. So I write that 0, negative 28, if I write it in point form. And what about x-intercepts?
Not applicable.
Yeah, we're not going to have any because it opens down. It's going to go down forever, but it's not going to go up past this point. And my x-axis happens to be up here, so it is never going to cross.